Okay, so we're going to do 4 example problems of polynomials. Remember, a polynomial is nothing more than a mini numbered expression. So we have 1, 2, 3, 4, 5, 6, 7, 8 terms in this polynomial. And our goal is to simplify this. And how do we simplify? We combine like terms. We make this as small as possible. We put everything together that can be put together. So, probably our first step is put this in standard order or standard form. All that means is we're going to go from the highest powered exponent, work our way down to the lowest powered, and eventually the constant, which is the plain number. Can you see in this example 7x plus 2 plus 2x squared plus 5x cubed plus x squared minus 10x cubed plus 15 plus 11x? Where's the highest exponent? 5x cubed and negative 10x cubed. So let's start rearranging. 5x cubed minus 10x cubed. Now let's look to the second power. There's 1, there's 1. So plus 2x squared plus x squared. Now to the first power. 7x and 11x. And finally we have 2 constants, 15 and 2. Okay, second, we can start to combine like terms. Well, I can see that if I have 5 of an x cubed, 5 of something minus 10 of something. 5 minus 10 is negative 5x cubed. 2x squared plus 1x squared makes 3x squared. 7 and 11, 18 x's. 15 and 2 is 17. And that's our final answer. X cubed cannot be combined with x squared because those are not like terms. 18 x's can't be combined with 17 because that's a constant, that's a plain number, and that's 18 x's. Now another approach is you could take this and you could use sort of a table and say, here's my cubes, my squares, my plane, and my constant. And we have a table kind of like this on the guided notes. And going back to the original problem, one way that you could do this, instead of the method that I showed you, another way is to just go across here. 7x, alright, that would belong here. 2, that's a constant. 2x squared, 2x squared. 5x cubed, 5x cubed. X squared, alright, that would go in this column. Negative 10x cubed. Negative 10x cubed. Put it in the wrong place. Negative 10x cubed. 15 and 11x. Okay, so you could sort of sort it into this table, and then we can just combine like terms in each column. 5 minus 10, negative 5x cubed. 2 and 1, that's 3x cubed, or x squared. 7 and 11, 18x. And 15 and 2, that's 17. Okay, same answer. Just kind of another approach for combining your like terms. All right, let's look at another example. All right, example number 2. So in this example, instead of just a long string polynomial, we have a trinomial, 1, 2, 3 terms, minus another trinomial. Now, one thing we need to just keep in mind right now is that the combining of like terms has not changed. You can still only add or subtract like terms. Well, another thing you may want to keep in mind is we are subtracting each of these things. You may want to draw those arrows just to help remember that that's happening. Let's use that table again. And I see the highest power in any of these is x squared, x, and a constant. Okay, so 2x squared, 5x, and negative 10. Always got to include the power in front of it. Minus a negative 5x. Minus a negative. I hope you remember that becomes positive 5x squared. Minus 2x would be negative 2x. And minus a negative 2, that would be plus 2. Alright, let's combine these like terms now. That's 7x squared, 3x, and negative 8. Or, as the final answer, you actually should write 7x squared plus 3x minus 8. Some of you are confused about whether that's a negative 8 or a minus. Well, when I'm talking about it all by itself, it's negative 8. When I attach it to the rest of the polynomial, that symbol is now between two numbers, and it's referred to as a minus. So anyway, why did I put a plus here? Because that was a positive number. We're combining like terms, we're combining terms, we're creating a polynomial. So as long as it's not a negative, we can assume it's a positive, and that becomes a plus once we put it between two numbers. So there's the final answer for this problem. So how about multiplying? Let's say we have this case. 3x, and we're going to multiply that by 2x squared, 10x, and 5. In other words, I have a monomial times a trinomial. Well, perhaps you would want to remember this is distribution. We're multiplying everything on the outside to everything on the inside. 3 times 2, 6. But we have x times x squared. In other words, x times x squared. If we use the rule that you've learned, which is this rule, that when multiplying exponents you can actually add them. 1 and 2 makes x cubed. Another way to look at that is x times, well, x squared is the same as x times x. That's what x squared means. So we have x times x times x, again, x cubed. Not to be confused with x plus x plus x. That would be counting how many x's you have. You have 3 x's. But when multiplying, we use the exponent to notate how many times it's been multiplied. So in this case, 3 times 2 is 6, and x times x squared, that was x cubed. Plus 3 times 10, well, that's 30, and x times x, that's x squared. plus 3 times 5, that's 15, and x times, well, there's no other x's, so it just is still x. Didn't become x squared or anything like that. None of these are like terms. They can't be simplified any further, so that's our final answer. And finally, let's look at an example of a binomial times a binomial. 2x plus 3 times 3x plus 5. Well, I could show you a variety of methods here, but let's make something quite clear. If we just had this monomial times that binomial, I think you can all agree that we would distribute. Well, what if it was just this monomial times that binomial? Well, again, I think you'd agree we would distribute. And that's exactly what we're going to do. It's a double distribution. This has to get multiplied to everything, and this has to get multiplied to everything. So 2x times 3x, that is 6x squared. X times x is x squared. 3 times 2 is 6. 2x times 5, that's 10x. 3 times 3x, well, that's 9x. And 3 times 5, that's 15. You'll notice here we have 10x and 9x. That can be combined. This follows the rule of combine like terms. Those are like terms. They're both plain x's. So my final answer is x squared, 6x squared plus 19x plus 15. Let me show you one other way. Actually, two other ways, that you could do this problem. You may have been learning something about the lattice method for multiplication at one time. So we can do that with this too, because we are multiplying. So I set up this binomial here and this binomial on the other side, and we're multiplying them. 2x and 3x is 6x squared. 3x times 3, 9x. 2x times 5, 10x. And 5 times 3, 15. Combine these like terms, and we end up with 6x squared plus 19x plus 15. Look at there. Same answer. And one other way I'd like to show you. 2x plus 3 times 3x plus 5 was our original problem. This is the same idea of double distribution, but there's a little pattern that some people learn called FOIL method, like Tinfoil. This stands for first, outer, inner, and last. Check this out. We're going to multiply the first things. That's the first thing in the parentheses. That's the first thing in the parentheses. Then the outer thing. This is the outer two terms for this whole binomial set. Inner terms. This is the inside. And last. Well, that's 3 is last in that parentheses and 5 is last in that parentheses. Okay? So this is our first, outer, inner, and last term. It's just another way of making sure everything in here gets multiplied to everything out there. We should get the same answer again. First, 6x squared. Outer, 10x. Inner, 9x. Last, 15. Don't forget to combine those like terms, always. 6x squared plus 19x plus 15. All three methods gave us the same answer. And what were we doing? Ultimately, we are multiplying a binomial times a binomial. So, I would recommend you go back and try these 4 examples now, again on your own. Here are the 4 problems that we just did. You can write them down and try them again yourself. And as always, good luck. You can do it.